Hi everyone, I'm Chu Junlin, a postdoc at the Department of Psychological and Brain Science at Dartmouth College. I'm very excited to show you some findings from our project linking inferences of traits and mental states. First, I would like to ask you a question. Imagine Olivia is at the gym. Which of the following mental state is Olivia more likely to experience, fatigue or enjoyment? They both seem possible, and we don't know anything about Olivia. I would just go with enjoyment. Let's see the correct answer. Olivia actually felt fatigue. Let's try one more. Imagine Olivia is at dinner with a romantic partner's parents. Appreciation or self-consciousness? Perhaps self-consciousness. That is correct. If we have the opportunity to learn about Olivia's mental states in different situations, we would start to feel that we know Olivia's personality or enduring traits. This is exactly the question we're interested in. Do people have a mental representation of how others' mental states and traits are linked? Here, we propose that people compress others' mental state information into a frequency distribution and link these mental state frequencies with traits. Using the learning paradigm we just saw, we manipulated how frequently a target person experiences certain mental states across situations. We did so by manipulating the correct answer in each trial. After participants learned about the target's mental state experiences, they reported their impressions of the target's traits. We found that changes in inferences of mental state frequencies meaningfully shape inferences of traits. Specifically, observing targets who experience more similar mental state frequencies cause people to predict that these targets have more similar traits. In the second experiment, we manipulated participants' inferences of targets' traits using different biographies. After viewing the target's biography, participants judged the target's mental states in different situations, based on which we computed the mental state frequencies. We found that trait inferences also produce meaningful changes in mental state frequency inferences. Specifically, observing targets having more similar traits caused participants to attribute more similar mental state frequencies to them. We further investigated the relation between mental state and trait inferences in more naturalistic contexts. In one study, we used Hollywood movies and home videos as stimuli. These stimuli are more naturalistic as they present targets dynamically, with multimodal features including face, body, movement, and with complex contextual information, mimicking the many encounters we have with strangers in everyday life. Participants viewed the videos and evaluated the mental states and traits of the people in the videos. In another study, we used participants' familiar people in real life as stimuli. Participants wrote down the names of their familiar people and evaluated them on different mental state frequencies and different traits. In both naturalistic paradigms, we found that inferences of mental state frequencies and traits are linked in people's mind. In summary, traits and mental states are not independent tools for understanding others. People compress mental states across situations into a frequency distribution and link that knowledge to traits. Change in mental state frequencies lead to predictable and consensual changes in trait inferences and vice versa. Importantly, this association generalizes to naturalistic contexts, including naturalistic videos and familiar others. These findings suggest that trait impressions may bias understanding of situation-specific mental states in a wide range of contexts. This highlights an important factor that makes understanding each other's thoughts and feelings difficult. Finally, these findings suggest that Thin slices of observations about others' uncharacteristic mental states may bias judgments of their enduring traits when we don't get a chance to observe many instances of their mental states. Thin slices of observations might be reliable signals for inferring mental states at that particular moment, but falsely assuming the reliability of those signals would extend to trait inferences may be the reason why thin slice and trait judgments are so ubiquitous. Finally, I would like to thank my collaborators and my labmates, and thank you all for listening.